Good morning everyone. As I have said, today we will be starting with XeF6 molecule, the preparation and the properties of the same. Okay. Now, if you could relate to what we have learned yesterday regarding the preparation and properties of XeF4 and XeF2, we will see that more extensive condition of pressure and concentration is required for the preparation of XeF6 molecule. Now here for the preparation of XeF6, as you can see, the ratio of xenon and fluorine is in the ratio of 1:20. That is 20 times fluorine concentration should be present in compared to xenon at a pressure which is 10 times more than that required for the preparation of XeF4. And temperature is 300 degrees Celsius. If you maintain all these conditions, then you get is XeF6. So the conditions are much more vigorous and much more intense, as you are forcing xenon to combine and expand its stable electronic configuration to the highest possible level of excitation. Next is under properties. Under properties, the first one is colorless solid, but here, unlike the other two, the vapor is greenish yellow in color. It's almost similar to color in that of your chlorine. It's almost similar in color to chlorine. Greenish yellow vapors you get. And significantly low melting point compared to the other one. That is 117.1 was for XeF4, and we saw it was around 150 degree for XeF2. So that has lowered significantly to 49.5 degrees Celsius. So as the valency of xenon increase, the melting point decreases. So this is a trend. Question may come from this. You are given 3 compounds, you have to arrange them as in the increasing or decreasing order of the melting point. So this is the order. Next is the oxidizing and the fluorinating property. Since over here XeF6, from the melting point you can find that it is the most unstable fluorides of xenon, therefore it has got the strongest oxidizing and strongest fluorinating property than any of the other 2 xenon fluorides. Strongest oxidizing and strongest fluorinating compared to the other 2 xenon fluoride compounds. Right? Now point number 3. Before you write point number 3, just write down xenon hexafluoride is reduced by hydrogen, HCl and ammonia gases. Xenon hexafluoride is reduced by hydrogen, HCl and ammonia gases to give elementary xenon, and hydrogen, chlorine and ammonia gets oxidized to their respective compounds in the products. So here if you see XeF6 plus 3H2, you get xenon. Here it was in +6 state, here it is in 0, elementary state. Hydrogen, here it was 0, here it has gone to +1. So there is a change in oxidation number, there is an increase, so oxidation. Similarly here, chlorine was in -1 state in the form of chloride. Here it has become 0. So -1 to 0, that's oxidation. And HF is what you get. Next is XeF6 plus NH3 ammonia. Here you get ammonium ion. Ammonium ion over here, why is it an oxidation? and just listen to this very carefully. This is addition of electronegative element to ammonia, hence oxidation. Nitrogen, it's further oxidized over here to give molecular nitrogen. So from -3 to 0 oxidation. So nitrogen is oxidized in both the compounds. Here the definition will be addition of electronegative element. Here it is increase in oxidation number in the form of nitrogen. Next is point number 4, that is these reactions. Before you start on, just give the heading, that is the compound XeF6 cannot be stored in a glass or quartz vessel. Quartz is Quartz, quartz vessel. Due to the formation of different xenon oxofluorides. Due to the formation of different xenon oxofluorides or oxyfluorides. If you see the reaction, XeF6 reacts with SiO2, that's glass or quartz, giving rise to XeOF4, xenon oxytetrafluoride, plus SiF4, silicon tetrafluoride. So glass has decomposed. This tetrafluoride of xenon in the form of XeOF4 combines further with silicon dioxide, that is glass, giving you XeO2F2, xenon dioxydifluoride, plus SiF4. Further, this gives XeO2F2 plus SiO2, which is XeO3, and if you remember XeO3 I mentioned, it is an explosive, xenon trioxide. So automatically what we will see is there will be a sort of mild explosion in the container in which you have kept the XeF6 if the container is made out of glass. So very, very important set of reaction. Mark this with a double star and you please make a note of it and study it with utmost sincerity. Next is point number 5. That is, here the reaction is hydrolysis of xenon hexafluoride. So here you can write that xenon hexafluoride reacts with water to form explosive compound xenon trioxide, and for this reason it is very, very, very difficult to handle XeF6 because a small drop of water will cause an explosion when it comes in contact with XeF6, right? So this is about the reaction or the hydrolysis of XeF6. Next is point number 6. Here we will study about the acceptor or the fluoride ion donor behavior of xenon X6, that is XeF6, and the fluoride ion acceptor behavior of the corresponding other molecule to form the addition products. So the first one is xenon hexafluoride with PTF5, platinum pentafluoride, forming XeF6 dot PTF5, which exists as XeF5 plus xenon pentafluoride ion and platinum hexafluoride ion. Arsenic pentafluoride in the same way exists as XeF6 dot AsF5, then XeF5 plus, fluoride goes there, AsF6 minus. Then the next one, XeF6 plus SbF5. Here also the same thing, the fluoride ion goes to Sb, and then you get this followed by the formation of XeF5 plus SbF6 minus. And then this one, similar type, BF3, so it becomes BF4 minus and XeF5 plus. Point number 7, before you go into that, just write one line. XeF6 reacts with fluoride ion donors to produce XeF8 2 minus species. XeF8 within the box bracket and 2 minus species as given in the following reaction. That is, cesium fluoride reacts with XeF6 giving CSF dot XeF6, which is in the presence of another CSF molecule forms CS2 XeF8, which is actually 2 CS plus XeF8 2 minus, because cesium can show only +1 oxidation state, therefore 2 cesium plus and XeF8 minus. So here in this XeF8 2 minus, xenon actually shows +6 oxidation state, although it is covalently bonded with 8 fluoride ions. Right? Next, with NOF, that is nitrosyl fluoride. If you remember, last day we had studied this compound NOF, nitrosyl fluoride with xenon hexafluoride. It forms NO2 plus. It is not NO2 plus. NO2, if you write over here, it becomes nitronium. That is not what we are doing. We are doing NO plus 2. XeF8 2 over here with definitely a minus sign. This is a 2 minus. This is what all we need to study about group 18. Please solve the questions of NCERT and I'll be giving you more questions to solve. Thank you and have a nice day.